Hello students, welcome to the second lecture of Basic Electronics lecture series. In the first lecture, we went through what is electronics, what is its origin, which are its types, which are the applications, what is the current status, what is analog, what is digital, and what is the future of electronics, including its applications. So today, we want to enter into the semiconductor physics review. So for that, let's go to the lecture content. As you can see, today our focus is on semiconductor physics review. So as you know, most of the electronic hardware industries nowadays are governed by semiconductor material, and specifically that material is silicon. Other semiconducting material is there that is called germanium, but there are many reasons people do not prefer germanium. One of them is silicon is cheap and abundantly available, while germanium is not so easy to obtain as well as it is costly. There are other reasons also for IC design, which we will discuss later on. So, why silicon is that much important and why that semiconductor physics is also important to review for operation of basic electronics, that we will see today. So, as you can see, by definition, what is semiconductor? Semiconductor is an element which has four valence electron in the outermost orbit. So outermost orbit is incomplete. So it is neither conductor nor insulator. And the famous examples of semiconductors are silicon and germanium. Atomic number of silicon is 14, while germanium it is 32. So atom of germanium is quite larger than silicon. So atom packing density is very low for germanium, so it is not preferred for IC manufacturing, and that's why silicon is predominantly used for electronic devices and ICs. You might have heard about Silicon Valley in USA. So it is not a physical valley, but it is a place where plenty of hardware and software companies of electronics are there for many years, and that's why it is called Silicon Valley. So now these silicon and germanium are pure semiconductors. So that means why they behave like that. So we need to refer to the band gap energy. So the two famous terms are conduction band and valence band. So let me clarify, if you have any doubt, conduction band and valence band are not physical things. They are energy levels. That means if you break an atom, you will not find valence band and conduction band, but they are energy levels. To understand it properly, let's imagine that one person has millions of rupees. So he is a millionaire. For example, he is a millionaire in valence band, but somehow he gets plenty of other money and he becomes billionaire. So now his level changes. It goes to conduction band. Likewise, if electron has less energy, we call it is in valence band, not physically but energy wise. And when electron gets energy, it goes to conduction band at higher energy. So for semiconductor, the band gap energy between conduction and valence band is 1 electron volt. It is equivalent to 1.6 into 10 raised to minus 19 joules. So if you look at this energy, it is quite small, very small, because our body energies are measured in kilocalories, while it is very small unit of joule. So you can imagine 1 ev is very small energy, but then also at room temperature, electrons are not able to get this energy and they are not able to go to the conduction band. So due to this reason, the semiconductors, their conductivity is neither similar to conductors nor insulators. So basically they cannot be used as aluminum, copper as conductors, and they can also not be used as insulators such as PVC. So basically pure semiconductors are useless. We cannot use them at all. So you must be surprised. If electronics depends on solid state semiconducting devices, then why pure semiconductors are useless? Reason is already understood. They cannot contribute to conduction, or they cannot prevent the current also. So now what to do? So the answer is you need to define three terms. First term is intrinsic semiconductor. In other words, it is pure semiconductor. So pure semiconductors without any impurities are called intrinsic semiconductors, which are silicon and germanium. And as I told, intrinsic or pure semiconductors are of no use for engineers, specifically for electronics. So now what is the solution? We have to add some impurity, some other material into pure semiconductor. So next term is impurity. So impurity is nothing but the elements which are added into pure semiconductors to make them impure. We will make them impure. So these impurities are of two types. The first category is trivalent. So all those elements which are having three valence electrons are called trivalent impurities. Examples are aluminum, indium, gallium, etc. The other category of impurity is pentavalent impurity. The examples are phosphorus, arsenic, antimony, bismuth, etc. So now these impurities will be added into pure semiconductor and it will make it extrinsic semiconductor. Combination of intrinsic and impurity makes them extrinsic. So look at the definition of extrinsic semiconductors. Semiconductors with added impurities are called extrinsic semiconductors. Now when you add impurities, you have two options. If you add trivalent impurity, something will happen. If you add pentavalent impurity, something will happen. So now we need to decide. Pure semiconductor has 4 valence electron. So if we add trivalent impurity in pure semiconductor, one electron will not get another partner to make a bond. So one covalent bond will be empty and that will create a hole, HOLE. So hole is not a physical thing, but it is a concept. That means absence of electron is called hole. So it is supposed to have positive charge because it is lack of electron. So if we add trivalent impurities in all pure semiconductors, we generate plenty of holes which are supposed to have positive charge. So that resultant material is called p-type semiconductor or positive type semiconductor, in which holes will be in majority and electrons will be in minority. Let's understand the second category of impurity, which is pentavalent. If you add pentavalent impurity in pure semiconductors, 4 electrons will form the covalent bond with silicon or germanium, but the fifth electron is free. So that means if you add pentavalent impurities, you will get plenty of free electrons in the semiconductor. And electrons will be in large number, so they will be in majority carrier, and holes will be in minority carrier, so the semiconductor is called N-type semiconductor. So these are the two main extrinsic semiconductors, p-type and N-type semiconductors. How they are generated we have discussed. So now using these two, you can form various semiconducting devices. So that means using extrinsic semiconductors, various electronic devices can be constructed. The famous one is diode, as you know. So let's see which are the electronic devices. So using extrinsic semiconductors, you can generate PN junction diode, which will be the first chapter of the basic electronic syllabus. Because there are two terminals, that's why it will be called a diode. Next is BJT, bipolar junction transistor. So this is the same which was devised by Graham Bell Laboratory in 1947 and 48, as I told in previous lecture. So that is called BJT or simple transistor. Then you can make junction field effect transistor, JFET. which is different than BJT. How it is different, we will see in future lectures. Then JFET is slightly modified and it makes MOSFET, metal oxide semiconductor field effect transistor. So it is nothing but modification of MOSFET. It has also two subcategories which we will discuss in later lectures. Then comes special purpose diodes. Only PN junction diode is not the only one. We can have LED, we can have photodiode, Schottky diode, pin diode, varactor diode, gun diode. So there are various semiconducting diodes which are electronic devices. And finally ICs, integrated circuits. You have seen number of ICs on your motherboard of your PC, laptop, RAM, ROM, those all are ICs. So these ICs can also be made from semiconducting devices. So the ICs may be linear or non-linear. Linear means analog ICs, non-linear means digital ICs. So you will get the detail in future topics. So these all are electronic devices starting from diode, transistor, JFET, MOSFET, special purpose diodes, integrated circuits. So now using all these devices, we can make circuits. Just see, if you combine all these electronic devices with resistor, inductor and capacitor, it will give you number of electronic circuits which we have to study also in our syllabus. So which are the electronic circuits now? The familiar one is rectifier, half wave, full wave, bridge rectifier, etc. Next one is filter. Filter is a basic requirement for audio and video applications. Nowadays we are using digital filter, but basic is analog filter. Then clippers and clampers, which are somewhat new for you, both the terms we will discuss in that chapter. Then amplifier is a famous word for you, which is very much used in digital Dolby sound applications as well as your mobile phones also. Then analog ICs for amplifier, mixer, oscillator, etc. Then digital ICs. You are familiar with logic gates, AND or NOT, NAND, etc. Those all ICs are digital. So they can also be made using electronic devices. Then memory devices, as I told, your hard drive of PC or laptop, your RAM, ROM also are constructed from electronic devices. Then comes microprocessor, microcontroller. Your automobiles, etc. nowadays are controlled by microprocessor controller. So they are nothing but ICs which are controlling the process. Now DSP processor, base of your mobile or any specific electronic hardware is nowadays DSP processor, digital signal processor, which is quite fast and having high data processing speed. So and so on. There are number of circuits we can make using electronic devices. So let's recall, how do we generate these circuits? These all circuits can be generated with help of electronic devices. Which are the electronic devices? Diode, transistor, JFET, MOSFET, special purpose diode, ICs. So that means devices are used to make circuits. So this is all about electronic devices and circuits. So the purpose of this lecture was to identify which are the electronic devices and how can you make circuits from those devices. So the purpose is quite fulfilled. You know what is semiconductor physics, how they are related with p and n type semiconductors, what can be the use of electronic devices in generation of electronic circuits. And in next lecture we will start with theory of PN junction diode. So till then, have a happy learning. See you in the next session.